Hello everyone. On this video we will be covering unit tangent vectors. Alright, so getting started. First thing we're going to do is kind of go back a little bit, okay, to just a regular ordinary unit vector. So a unit vector, remember that's the u vector, which is equal to a vector over the magnitude of a vector. Okay, and what that does is just a vector in the same direction as whatever your a vector is. The only difference is it has a magnitude of a. Of 1. Sorry about that. And remember, magnitude is just a fancy way to say length. All right. So, what if we let C be a smooth curve and our R vector is a vector on an open interval that we will call I. Okay. Now the unit tangent vector, should have a capital T there. Okay, now your unit tangent vector is a little bit different. And that's your uppercase T vector of T is equal to R vector prime over the magnitude of R vector prime. You kind of separate that a little bit, make it a little bit closer than I want it. And that's, of course, if your R vector prime does not equal 0. Okay. Now, the difference between the two is that the unit tangent vector is in the same direction as your tangent line vector, where the unit vector is just in the same direction as your vector in general. Okay, so if you want to get a different unit vector for just a plain vector, you'd use this one. But if you wanted to get the unit vector that's in the same direction as your tangent, then you use this one. Okay, so make a little side note there. The unit tangent vector represents a vector in the direction of the tangent vector. And also has a magnitude of 1. All right, so they both have the same general idea, they just perform them for two different types of vectors. One's a regular vector, one is a tangent vector. All right, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our first example. right, so for example, what if we wanted to find the unit tangent vector to the curve? Okay, so let's say r of t is equal to t squared times your I vector plus 2t times your j vector at the parameter value of t equals 1. All right. So we know that our r vector is equal to t squared times I vector plus 2t times your j unit vector. Okay, now we just have to find the derivative. So r vector prime is equal to derivative of t squared is 2t times your I unit vector plus derivative of 2t is just 2 times your j unit vector. All right, now that we have that, our unit tangent vector is equal to r prime over magnitude of r prime of our vector. Okay, so r prime of t is 2t times the I unit vector plus 2j, which we just figured out, over the magnitude, which is the square root of each of your components squared. So you have 2t squared plus 2 squared. Okay, so we can go ahead and factor 2 out of both of those. So 2 times t times I vector plus j vector over, you have 4t squared plus 4. And the square root of that. Okay, so continuing on the next line, we have 2 times t times I vector plus j vector over, we can factor 4 out of both of those. So if we factor out that 4, that would be square root of 4 times the square root of t squared plus 1. Okay, so we see the square root of 4 and the 2 cancel each other out, so it's the same thing. So we end up with a unit tangent vector, t times I plus j over square root of t squared plus 1. Okay, so that's our unit tangent vector. Now we have to find the unit tangent vector at t equals 1. Okay, so that unit tangent vector at t equals 1 is just equal to 1 times I plus j over the square root of 1 squared plus 1. Okay, which is equal to 1 plus 1 is 2, so you have square root of 2 in your denominator, so you have I plus j over square root of 2, or 1 over square root of 2 I plus 1 over square root of 2 j, or you can rationalize the denominator and make it square root of 2 over 2 I plus square root of 2 over 2 j. Okay, and that's your final answer. Okay, quick side note. In case you were wondering, the magnitude of the unit tangent vector at t equals 1 is equal to the square root of each of those components squared. We have square root of 2 over 2 squared plus square root of 2 over 2 squared. It's equal to square root of 2 squared is 2, so you have 2 over 4 plus 2 over 4, which is square root of 4 over 4, which is just 1. Okay, so all we did here was just kind of verify that the magnitude of a unit tangent vector is equal to 1. Alright, so if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. Alright, so for this example, we have to find the unit tangent vector and we also want to find a set of parametric equations. For the line tangent to the space curve. Okay, so our curve, our vector t, is equal to t times your I vector plus t squared times your j vector plus t times your k vector at the point 0, 0, 0. Alright, so to solve this one, first thing you want to do is you want to figure out, okay, what value do I have to make t in order to make our vector equal our point, or our terminal point. Okay, so to make our R vector equal 0, 0, 0, we just make t equal 0. Okay, because you have 0, 0, 0 for all of your components. Okay, now we're going to use that in a second, but first we have to find our R prime of t. Okay, so derivative of t is just 1, so that leaves us with just our I vector. Plus derivative of t squared is 2t, so you have 2t times your j vector. Plus derivative of t is just 1, so you have your k vector. Now we want to find our, let me straighten that up, tangent when t is equal to 0. Okay, so when t is equal to 0, R prime of 0 is equal to, if you plug in a 0 here, there is no t, so it just stays I. If you plug in t equals 0 here, that whole thing disappears, so it's just 0j. You plug in t equals 0 here, there is no t, so that stays the same. So it's just I plus k, or you can make that equal 1, 0, 1, since there is no j. Okay, so now we have to find our unit tangent vector at 0. So our unit tangent vector at 0 is just going to be our r prime at 0 over the magnitude of r prime at 0. Okay, so that's just going to equal our r prime of 0 is 1, 0, 1 over our magnitude, which is the square root of 1 squared plus 0 squared plus 1 squared. Okay, so really what you do is you move that out to the front. You have 1, 0, 1 times 1 over square root of 2. Okay, so that means that our unit tangent vector at 0 is equal to 1 over square root of 2, 0, 1 over square root of 2, which is the same as saying square root of 2 over 2, 0, square root of 2 over 2 if you rationalize the denominator. Okay, so you can use this way, or you can make it square root of 2 over 2i plus square root of 2 over 2k. So either way, this is your unit tangent vector at 0, 0, 0. All right. Okay, so now we just have to find our parametric equations. And I'll just separate that a little bit. Now, since r prime of 0 is equal to 1, 0, 1, right up here, and our initial point is 0, 0, 0, you know that initial point is our x0, y0, z0, and this is our A, our B, and our C. Okay, so these are your direction numbers. So all we have to do is go back to our parametric equations. Okay, so you have x equals x0 plus a times t, y equals y0 plus b times t, and z equals z0 plus c times t. Okay, so if you plug all those in, that means x equals 0 plus 1t, y equals 0 plus 0t, and z is equal to 0 plus 1t. All right, so in other words, you have x equals t, y equals 0, and z equals t as your parametric equations. All right. So If you are still writing, feel free to press pause, but we're going to go ahead and go to our next example. All right, so for example, we want to find the parametric equation. And clean that up a little bit. There we go. For the tangent line to the curve with the parametric equations x equals e to the power of t, y equals t times e to the power of t, and let's say z is equal to t e to the power of t squared. And all of that at the point 1, 0, 0. All right, so we're going to go ahead and solve this one. Okay, now the first thing we have to do is we have to find out what t value will make our r of t equal this. Okay, so this is your x, your y, and your z. Remember, you can always make it r of t is equal to e to the t, t, e to the power of t, and t, e to the power of t squared. Okay. Now, we want to make this equal 1, 0, 0. Kind of separate that a little bit. So to make r of t equal 1, 0, 0, how do we make this equal 1, 0, 0? Well, easily enough, we just make t equals 0. E to the power of 0 is equal to 1. 0 times whatever is going to equal 0, and 0 times whatever is going to equal 0. So we just make t equals 0. Okay. Now, it won't always be t equals 0, but for these examples, it just happens to be t equals 0. Okay. So now we just have to find our r prime. So r prime is equal to derivative of e to the t is e to the t. Derivative of t e to the t is first times derivative of the second, so t e to the t, plus the second times derivative of the first, which is just plus e to the t. Okay, now for this one, we have the first times derivative of the second, so you have 2t squared e to the t squared plus e to the t squared. All right. So now we plug in our t equals 0. So when t equals 0, we know that your r prime is equal to, of course, e to the 0. You have 0 e to the 0 plus e to the 0. You have 2 times 0 squared e to the 0 squared plus e to the 0 squared, which is just e to the 0. Okay, so that means your r prime is equal to 1, 1, 1. Well, r prime of 0. Should replace that in there. is equal to 1, 1, 1, because that cancels out and you're left with 1, 1, 1. All right. So now we know that the unit tangent vector is parallel to the tangent line. And that's the one thing we figured out on our last video when we first introduced tangent vectors. Since we know the unit tangent vector is parallel to the tangent line, that means for our r prime at 0, which is 1, 1, 1, and our original point, which is 1, 0, 0, we know that this is our A, our B, and our C. And we know this is our x0, y0, and z0. Okay, so just like before, we go ahead and plug those right into our parametric equations. Okay, so x is equal to x0 plus at, y is equal to y0 plus bt, and z is equal to z0 plus ct. Okay, so you have x0, so you have 1 plus 1t. So that's 1 plus t. Y is equal to y0 plus bt, so you have 0 plus 1t, which is just t. And z is equal to 0 plus 1t, which is just t. Okay, so these are your parametric equations. Oops, sorry about that. Alright, so hopefully this video made sense, and I will see you on the next video.